For a floating body, buoyant force act at the option A, center of the floating body, option B, center of gravity of the body, option C, centroid of the fluid vertically below the body, and option D, centroid of the displaced fluid. Let's understand this problem using a diagram. The diagram here represents partially submerged body and a fully submerged body. Now in a partially submerged body, we can see that the center of buoyancy lies below the center of gravity, and in fully submerged body, the center of gravity and the center of buoyancy coincides. What is the significance of these center of buoyancy and center of gravity in here? When a body is either fully submerged or partially submerged in a fluid, a lift is generated due to the net vertical component of hydrostatic pressure force experienced by the body. Okay, either it is partially submerged or fully submerged. The lift is called buoyant force and is represented by Fb. Okay, so in both cases we can see the buoyant force, and the phenomena is called buoyancy, of course. Now according to Archimedes' principle, the buoyant force Fb, this force on a submerged body, is equal to the weight of liquid displaced by the body. Below this white dots, the hashed part will be the volume of liquid displaced by this body, right? And it will act vertically upward through the center of displaced volume. So this is the displaced volume, this volume below this white line. This point B is the centroid of displaced volume and is called center of buoyancy. Okay, for fully submerged body, center of gravity and center of buoyancy coincides. So the centroid of this whole body, when it is fully submerged, will be here at the center of gravity. Thus the net force on the submerged body, you can write Fb will be equal to the density of the fluid multiplied by the acceleration due to gravity multiplied by the volume it displaces. Let's write V displaced volume. So V dis represent displaced volume. Therefore, this buoyant force depends on the density and the displaced volume. Fb depends on density and displaced volume. Okay, so to conclude, I can say that the buoyant force act the center of buoyancy, which is center of the displaced fluid. Okay, so from here we can say option D is the correct choice. For more details, you can refer to the NPTEL course lecture number 6, buoyancy, metacenter, stability and rigid body motion on fluid mechanics by Professor Subhashisha Datta of the Department of Civil Engineering at IIT Guwahati.